Hello, good morning, everyone. It's a pleasure to be here in Tirana. It's a pleasure to be here at Faber. First of all, I would like to thank the organization, to thank in particular Jole Sakolka for this kind invitation. Let's begin. I will start with this number, 2 billion homes. Over the next 50 years, UN estimates will need to build about 2 billion new homes, and it represents a massive increase in demand in a very short time frame. So, put simple, we'll need to build a lot and fast. And the slow pace of the traditional construction, as we all know, won't cut it. As demand grows, supply tends to decrease. So in the moment in the human history when we need more buildings than ever, contractors complain that they don't have enough workers to raise them. So these two facts, beside to applying to our pragmatism, they somehow pose a central challenge to architecture, which is the optimization of time and physical resources. Two images. On the left, we have the first line of Ford's motors, the first assembly line. On the right, we have the Sears Homes catalog. Sears Homes was a company that sold thousands of houses in the first half of the last century. Those houses were ordered by postmail, and they would be assembled by the clients themselves from kits. So these two images, they have two things in common. The year, they are both from 1913, and the fact they both represent thriving industries at the time. So more than 1 century later, it is enormous, this disparity in between the evolution of the automotive industry and the construction industry. Of course, we always have exceptions, but generally speaking, that's how we produce cars today, that's how we produce buildings today. And that's this delay of the construction industry that we are, let's say, fighting, and we started 10 years ago doing it with, I would say, very modest means, far from the sophistication of the automotive industry, and we just found a way to divide this prototype, this house, into 5 modules that were fully ready on factory with all the claddings, the window frames, the furniture, etc. And we just assembled it on site in just 3 days. It was our first project, so it still has this special place for us. But I always reinforce that we didn't invent this. We just took the idea of the old sewer pipes and we redesigned it in order to make it habitable. That's why I love this sentence from Jonathan Keats for Forbes magazine. This project shows how the most readily available solutions are often so commonplace as to be practically invisible. So our job as architects sometimes is not just about to invent, it's also about to unveil those hidden solutions. And it was this idea of transposition from an infrastructural system to an architectural system that we presented with this installation in the Venice Biennale in 2016. So we wanted to show that these 3 different pieces, they are brutally different in shape, they are brutally different in dimension, in use, but they are just the same in construction, in tectonic terms. And again, reinforcing this idea of transposition, of readapting rather than invention. It is a project 70 years older than ours, the Aero House, and they were already using the same concept. We use concrete, but I would say that the tectonic concept is quite the same. I mean, slices of the construction fully ready from the factory and assembled on site very quickly. Or the zip-up house from Richard Rogers, again, is not innovation at all, is reprocessing. So I would say that the history of prefabricated architecture is being built with cases like that. I mean, similar solutions being applied by different architects. So it works as some sort of ecosystem of ideas that some architects manage to materialize. After La Biennale, we got some commissions to develop some projects with this three-dimensional modular systems. This is one of them, these 11 cabins in the woods, in this hilly plot. But in this case, we needed to divide each module into two submodules, so a base and a top. The access was so difficult, the plot was so remote that we needed to divide the module so that we could divide its weight, because we could not take the big crane that normally we use to assemble those modules. So this way it was possible to assemble the modules with a smaller crane, and in off-site architecture, I would say that logistics are always part of the design. So we just started by placing these units over the hillside, combining different positions with different orientations to make sure that every unit has a view for the landscape and for the river. So rather than rooms, they work as small houses, so some of them may function as long-term accommodations, so they are not exclusively touristic and seasonal units. And we might have these different typologies by combining more or less modules, by placing them horizontally or vertically. And we also use this project to start a new experience with this building system. Before, all the technical installations were inside all the modules. In this case, we did something different. So we concentrate all the technical parts, I mean the water, electricity, and climatization in this central module here. So this is a central technical module. And these technical installations, we take it to the rest of the house externally. So these central modules take longer to be produced, but all the others can be produced automatically with very little man intervention, taking roughly half of the time. So that's why you see here the cable flying under the ceiling externally. Well, here we have the connectors between the different modules. They basically work as a central ring and two screws. Each goes to the correspondent module. And the more we tighten these screws, the more we pull the modules together. And inside the joint, we have an asphaltic rope. And when we tighten these screws, we just smash this rope. And this is what makes the joint completely watertight. And as you saw before, this project is very close to the river, so we never know what will be the level of the water in the future. So at some point we can just remove those connectors and we can move these modules, we can move this building somewhere else. So we make this effort to work with dry connections so that we can approach this concept of design for disassembly as a strategy to potentially extend the life cycle of materials, the life cycle of the building components beyond the building itself. And why is it important? It is important because we demolish too much and we produce far too much waste in the construction industry. In the United States alone, every year, more than 100 million square meters of existing buildings are demolished and replaced by new one. 100 million square meters. We have been calculating the weight of the CO2 emissions of the construction processes of our buildings, and we are getting per each square meter values such as 80, 250, and 400 kilograms of CO2 when working with wood, steel, and concrete, respectively. So this is the invisible environmental weight that we need to acknowledge. And, we as a society, we, reuse and we recycle everything from plastic, clothes, bottles, everything but buildings. And trust me, the building industry is the most pollutant one. And I believe that through its potential for reuse and modular reassembly, off-site architecture is a powerful tool to tackle this problem to tackle the construction weight. A different project with B-dimensional prefabricated elements is started from a public competition to a sports center to design 2 grandstands and 1 building, you know, the typical sports center building with locker rooms, a bar, a medical center. And the 2 main factors in the evaluation of this competition were the building price and the construction time. So we compacted all these different elements of the program into a single structure. So we have the grandstands one against each other. Underneath, we place the buildings, so the grandstands also work as the roof of the building at the same time, and all of these share the same structure. So with this, let's say, compactation strategy, we managed to accelerate the building process and also to do it in a very affordable way. So it's a very, let's say, pragmatic and austere building, and I would say that it is self-explanatory. Above, we have 2 grandstands. Below, we have a building. And it takes me to the project of the St. Andrews Students' Residence from James Sterling. The influence is quite obvious, and I'm not just talking about using these big concrete panels as structural elements, but how we are using it to, you know, to influence the design of the facade. So again, when working with off-site solutions, we are always working with references. And we are always studying these references. That's why we developed this virtual exhibition, curating a group of 25 building systems that we considered important in the historical evolution of prefabricated architecture. And you know, in this exhibition, we just showed the classical triptych of any architecture exhibition. I mean, images, texts, and models. But we do it in this virtual way, so it is almost an immaterial exhibition. And by the way, we have been showing this exhibition in 7 or 8 countries, from Portugal to US to Germany to Scotland. But its very, very first edition was here in Tirana 7 years ago in the frame of the Tirana Architecture Week. So it's good to be back. Okay, in this project, we used again these big prefab elements in concrete, 6 small apartments in the upper floor, and undefined multifunctional space in the ground floor. All the structure is off-site, it is produced and stored in factory. And then, when it's the right moment, it is just assembled on the site in a very quick and clean way. So we used those panels in the ground floor, bidimensional. We used these volumes, 3-dimensional, in the upper floor, both with insulation from the factory. The front of facade quite open, facing the public. So I would say that through this image you can understand the structure of the whole building. The back facade is quite more private. The idea here was to design and licensing this building as a collective housing building, but keeping some of the advantages of the individual dwellings, such as this complete acoustic separation in between the different units and also the single entrance per each unit. Here we have the constructive details, so we have concrete inside, concrete outside, but we always have insulation in the middle. And those are the pieces as they leave the mold. Again, the pieces as they leave the mold. We have concrete inside, concrete outside, no additional paintings, no additional materials. What means reducing the manpower needs and also the materials involved in the construction process, which also means saving time and money. But you know, working mainly in the factory and reducing these on-site works, it doesn't mean only rapidity. It also means giving better and safer conditions to the workers who operate under a roof. rather than the extreme weather conditions that sometimes we verified in the building site. And it also means less disturbance in the surroundings. And it is very important, especially when we work in crowded urban areas, such as here in Tirana, so we can get, building sites with less dust, less noise, less traffic limitations. And it was very important for us. For example, in this project, it was 4 kindergartens that we did in central areas in Lisbon, in Portugal. So we started from these U-shaped modules. So these modules were the simplest and the most production-wise efficient modules that we could find to respond to this program. And, when working with off-site architecture, this is always part of the deal. I think that we as architects, normally we think about the final shape and just then we think how we'll build it. And with off-site elements, sometimes we need to flip this process. Sometimes we need to start from the elements we have, in this case, these U-shaped elements, and only then we can think about the final shape of the building. And in this case, it is very clear. I mean, the final building is just the result of combining, of joining these different modules, and it is quite understandable. This is legible from the exterior of the building. So the next year we started experimenting new materials, new processes, especially bio-based materials. It was our first experience in this 5-unit housing building, experimenting this rice husk as the filling and isolation layer in the roof of the building. Then we transpose it to vertical prefabricated panels, and later for these U-shaped elements with this external layer of rice husk. So in this case, this external layer, it works as the outer cladding, but also as the thermal insulation of the building. So we used again the same pieces we used in the kindergartens to build this small prototype using this rice husk external layer. Okay, I'm just finishing the last project. Here we have 48 apartments. We have been working a lot with public housing in Portugal right now. This is one of these projects. It is the first time that we are working with three-dimensional steel modules. So what we have here is some steel frames that are cladded, finished on factory, then they are stacked on site. So it is a clear example of prefabricated, pre-finished volumetric construction, so PPVC. In each module, we have these 4 square all sections tubes working as pillars, let's say. And inside those pillars, we run these DWDAG threaded bars that clamp vertically the modules together. So inside, we cast, in the traditional way, these 2 central cores with the elevators, with the staircases. They are essential for the seismic performance of the building. And at the same time, we are preparing those steel modules. And then we just set them in place. We anchor them to the central cores. And in the perimeter, we apply this flashing to make sure that the horizontal joints between the different modules is completely watertight. So in each floor, we have 28 modules composing 6 2-bedroom apartments. So it is public housing. They will belong to, these apartments will belong to the municipality forever. So in this scenario, flexibility was very important. So in these 2 central apartments, we just added this movable wall so that we have 2 2-bedroom apartments today, but tomorrow we might have 1 3-bedroom and 1 1-bedroom apartment. As I said, the concrete cores being cast on site at the same time that the modules are produced in factories, so no time wasted. And last week, we just started applying the modules on site, so I hope that this image will become reality soon. And through this presentation, I've been talking about, logistics, clever techniques, numbers, and it is all important, but we still need to make it beautiful. That's, I would say, what architecture owes to people. That's no negotiable in architecture. So maybe I was not clear enough about that today, but there is always much more to design than just technical optimization, and this is what we strive for. Thank you very much.